So suppose that I'd like to determine an asymptotic expression for this integral. We're going to use steepest descents. Remember the way that it works. Everybody in the exponent. That is our first step. Throw everybody into the exponent. All right, x is e to the natural log x. So x to the nx is e to the nx natural log x. Step 2, write out the exponent and its first two derivatives. I want you to say all right, step 3, find the maximum, the value of x that maximizes the exponent. So I would set this equal to 0. Now, unlike what we've seen so far, this equation is not one that we can solve algebraically for x. It is a transcendental equation. Does not have an algebraic solution. Here's an example of another transcendental equation. Cosine x equals x. I cannot solve this equation algebraically for x, even though one look at a graph indicates that there is a perfectly well-defined value of x that satisfies this equation. I just can't write it algebraically. But that's fine. We're doing numerical analysis anyway. All right? So we're just going to solve it numerically. Suppose that the value of x that satisfies this equation is xn. It depends on n. All right? Step 4. Make a Taylor series expansion for the exponent centered at the maximum value. So I do the value at xn. G prime of xn is 0. That was how we determined xn. So then it's just going to be g prime prime. I'm going to write like this. Over 2 factorial just like that. All right? Step 5. Truncate the Taylor expansion at the quadratic term, throw it into the integral, take out the constant, and integrate the rest as if it was a Gaussian, because it almost is. All right? So the way that that process works is like this. We have integral 0 to infinity e to the minus xn squared plus nxn log xn times e to the minus 1/2 Oh, this should be xn. 2 minus n over xn, x minus xn squared dx. All right, now, this is a constant. Goes out front. This piece, I'm only integrating from 0 to infinity. So it's like the integral that I want to do is this one. I'd rather integrate from negative infinity to infinity, because then I could do a trivial shift, u equals x minus xn, and it'll become a Gaussian integral, and we can complete it real easy. All right? When x equals 0, this is e to the minus positive number times xn squared. Now, we were not able to solve this for xn. However, if you look at what the equation says, it says 2xn minus log xn is equal to n. So that means xn should be largish. It should be on the order of n. So e to the minus number times xn squared. That's really, really, really small. So all we're saying is, let's approximate this by saying, I don't want to calculate blue, I'm going to calculate red instead. And we're arguing that this piece doesn't matter. We're only looking for an asymptotic expression after all. All right, we're not interested in getting this exactly. So what we would get is e to the minus xn squared plus n xn log xn square root of pi over alpha. Pi divided by this coefficient. 2 pi divided by 2n divided by xn. All right? This is not an equals. Approximately. All right? We can simplify this a little bit more by making use of the fact that xn satisfies this equation. So that means n log xn is equal to 2xn minus n. And look what we've got here. Minus xn squared plus xn times n log xn, which is 2xn minus n. All right? So we could modify this by making it e to the xn squared minus n xn, or e to the xn times xn minus n. All right, so this will be our asymptotic expression for this integral. I'll write it up here. E to the xn times xn minus n square root of 2 pi divided by 2 minus n over xn.